Question number 13. Given the graph below, what is the slope? So we are going to look at our graph and we're going to count our slope. Remember that slope is going to be rise over run. And we are going to count. So we have to find points to count from. A really good point that we can use is right here. And that one actually has a special name. That's our y-intercept. And as I'm going along my line, I'm not seeing any other good points until I get to that one right there. That's a good one because it goes through the corners of your squares on your graph, on your grid. So we're going to start with these dots and we're going to count. And I like to start on the left one because that's going to help you more likely get a more accurate answer whenever it happens to be a negative. So we're going up. Up is positive 1, 2, 3. Going up is a positive 3. So our rise is 3. Run is 1. And when you have 3 over 1, that is the same as 3. So what is the slope? The slope is 3. What is the y-intercept? So our y-intercept, that's what we said before, it's crossing the y-axis right here. So this is our y-intercept. And on your test, I believe this is a griddable question, and so the answer is just going to be as simple as 2. If it asks you, which it will on your end of semester test, the CBA that we're going to be taking after Unit 5, it's going to ask you for coordinates also. So I'm going to go ahead and remind you of that. Whenever it asks you for a coordinate, we go sideways. To get to that dot, we go sideways 0, and then we're going to go up 2. But on this test, again, it's a griddable, and you cannot grid a coordinate, so you will have to stick with just 2. Number 14, write an equation of a line that contains this point and is perpendicular to y equals 2x plus 4. So again, we have two things that you can type into Desmos. And so I'm going to go ahead and pause and let you guys type in both of these things that have the pink box around them. And at this point, I don't really have an easy answer. I just see a line and a dot. So now we're going to have to do some work. An important word, perpendicular. Remember, perpendicular means that we're going to go like this. So when you're looking at the picture that you're given, let me take a picture of what we have on Desmos. And we'll talk about how to graph it by hand also, because that's really important. This is just going to serve as a check to make sure that we're doing it right. All right. So when we graph this by hand, we're going to graph our y equals mx plus b. Our beginning dot is going to be at 4. 1, 2, 3, 4. And then we're going to do a slope of 2. How do you make 2 a fraction? Put a 1 under it. So that means go up and to the right. So we're going to go up 2, right 1, up 2, right 1. We can also go down and backwards. And that's going to be our line right there. And we're going to pretend that goes through all the dots. And then we have 4, 1. Remember x, y. So we're going to go forward and we're going to go down. So we're going to go forward 4 and down 1. And so we need a perpendicular line. So our line is going to have to look something like, it's got to go kind of, again, pretend that's straight. It's going to kind of have to go like that so that it makes our right angle over here. Okay? So what kind of line is this? Whenever you start at the left and you go this way, it's going to have a negative slope. So maybe that might remind you about our rules for perpendicular. So our slope was 2 in this equation that's given. whenever I want the slope that is perpendicular to that, and so I just drew the perpendicular symbol, remember that we have to flip the fraction, we have to flip the slope, and we also have to change the sign. So when I flip 2, I can make that a fraction, remember, and when we flip it, that's 1 over 2. And then we're going to change the sign so it's going to be a negative, and that's actually what we're looking at. So we're not going to use this one in the equation, we're going to use that negative version. And now I have a point and a slope. So what formula can we use? We can use the one that says point slope. You do not have to have that memorized. You can look at your formula chart. That formula is y minus y1 equals m parentheses x minus x1. So we're going to plug in our numbers. So we have y minus, and then we're going to come up here, and our y1 number is going to be negative 1. And then that equals m, and our m number that we just found was negative 1/2. And then we're going to use parentheses x minus, and then we're going to have our x number, and our x number is right here, 4. And then we're going to go through and we're going to do our solving steps. So when we start to solve, we are going to simplify. Subtracting a negative, we turn that into a big old plus sign. So this says y plus 1 equals. And then we have the negative 1/2 right next to the parentheses. And so we're going to multiply, we're going to distribute. Negative 1/2 times x is negative 1/2 x. Negative 1/2 times a negative 4 is going to give you a positive 2. And if you need to type that into Desmos, you can. Again, negative 1/2 times a negative 4 is a positive 2. And then your last step in solving is going to be to get that into y equals. So to undo plus 1, we're going to do minus 1 on both sides. These zero out. So we have y equals negative 1/2 x. And then negative 2 plus 1 is going to be a positive 1. If we want to double check this, we can go type this in on our Desmos. I'm going to go ahead and graph it by hand since I have this graph here. I'm going to leave that one there so that I can see what it was going to be. So I have a positive 1, and I'm going to go down 1 and right 2. So go down 1, right 2, down 1, right 2, down 1, right 2. And if you'll notice, it went through that dot that we had, which is good because it's supposed to contain the point that was given. And it is kind of in the same spot that I sketched out. Not exactly, but this one is going to be more accurate. And that does make your right angle. When you type this one into Desmos, you can see it really accurately. 1 divided by 2x plus 1. And make sure that whenever you type in that x, it is not in the bottom of your fraction. Here we go. Here's our picture. So you can see it does make that right angle on our Desmos. Question number 15. A convenience store manager notices that sales of soft drinks are higher on hotter days, so he assembles the data in the table. Pretty much as soon as you see a table, you should have a thought that what am I going to do with this? I need to go type it in. This is going to be your x value. This is going to be your y value. And it will be a horizontal table on the test as well. So you need to be able to determine where to type those values. So we're going to have our x values. I'm going to give you a moment while I'm typing them in so that you can type these in as well. So everybody at this time should be typing this in. You're going to get on your Desmos and you're going to press the plus sign. You're going to add this table. This table is not doing any calculations for you. You are typing in all of these answers, so you start off with that plus sign. So everybody type in the table right now. as you're typing, make sure to be careful and check yourself so that you don't have any typos, because that will change some of the results that you're getting, and you want to be accurate. What does the correlation coefficient for the data indicate about the strength of the linear association between the high temperature and the number of cans sold? So right now, as I'm looking at my Desmos, I'm not seeing any of these dots. And the reason is, if we look at the numbers, it can be a little bit more clear. These numbers are in 55, 58, and so on. The bottom numbers, the Y values, are in the 400s. So what we're going to do is we are going to change our scale. We can zoom down till we find our dots. I need to come this way. There they are. And so we see all of our dots. And to me, I can see that the slope looks like it's going to be positive. And all those dots are pretty close together. So that says strong. But the question is actually asking you about your correlation coefficient. And so you see that whenever you ask Desmos to type a line in for you. And so the way that we do a line, remember, is y equals mx plus b. And if we're asking Desmos to look at the information in the table says x1 and y1. So again, what we're going to do is we're going to change this to y1 worm equals mx1 plus b. So everybody go type this in on your Desmos at this time in a new line. And when you type that in, it will put a line through all of your dots, and it also gives you your R value. So what we're going to do is we're going to look at that R value right here, and it's 0.9673, 0.9. So 0.9 for our R value was 0.9673. 0.9 is very close to 1, and 1 means that our line goes perfectly through all of our dots. And so this is very close to that, which means it's going to be very strong. 0.9 is also a positive number. So it's going to be not negative, but it is going to be positive. And you can also see that from the picture that I showed you, that it was going up like this. So your answer is D, strong positive. And this question kind of goes with question number 16. Give an example of a correlation coefficient that would be weak and negative. A weak negative correlation. So that means that your R value would have to start off with a negative sign to be a negative correlation. And then a weak number would be anywhere from like a 0 to maybe like 0.3. So a weak correlation could be any number between there. So you can do something like 0.217, or you can do, there's infinite number of possibilities as long as you have a negative on the front, and then this beginning value right here is less than 0.4, probably would still be considered very weak. So that's what you're looking for. Even something like a negative 0.02, that would be extremely weak. I think that would be a really good answer. Anything that starts with a 0.0 would be very weak. Please make sure that as you are looking through this, you're not just copying it down.